So, combination circuits. What happens, what do we do when we've got a combination, series and parallel parts in the circuit? The thing to note is we put up a nice circuit diagram and labeling it properly. So, we're being asked here, give some values. So, E is 30 volts, R1 10 ohms, R2 30 ohms, R3 50, and R4 15 ohms. So that's the information we'll be given, all the resistor values and the supply voltage. Find all unknown voltages and currents. Yep. So we got current IT flowing there. We've got a volt drop V1 across there, V2 across the parallel, and V across the R4 resistor. And we got I2 branch currents in the parallel part. So we combine them both parallel. You could that I1 there, so I'd T, yeah? Alright. So what could we so yeah, we could calculate yeah. What we could do though is calculate all of RT in one go, because what we're going to do after we calculate the equivalent of combination to get the total, add the other two up. So why not do it all in one go? R1 plus R2 times R3 over R2 plus R3. That's the middle bit, plus R4. Don't mind if you do it separately. See, if you just calculate this middle here, call it R2 and R3 combined. Don't call it RT. It isn't RT for that circuit. Alright? It's the combination of those two together in parallel. So when we've done that, we put the values in. So that's 10 plus 30 times 50 over 80 plus 15 equals. We'll go with 43.8 then, yeah? Three significant figures. Okay? We didn't ask us for that, but that was the only thing we can calculate at the start of that question. Because we got no current, we've got no individual voltages, all we got is the resistor values and the supply voltage. So the only thing we can find is total resistance that will allow us to find what? What can we find next? IT, yes we can. How do I find that then, young Lewis? That's 30 and 43.8 equals. Three significant figures, please. .685 to three significant figures, amps. Yeah. So I'm going to go on the board diagram as well in case we need it. 0.685 amps. What will the fact that we now know and also there, what can we do now? If you want to find these two currents, that's got to be one. Yeah. Remember, you could draw this circuit as three resistors in series, with that one being R23, the combination together. Alright? What voltages can we find easily now? Remember, we've got to focus on one resistor now. Find the volt drops. Yeah, we could find one. V1 is equal to I. Where did E come from? Voltage is equal to Ohm's law. I, we're talking about IT is through that resistor, isn't it? Current flowing through it at IT times R1. That's the 0.685 times 10. 6.85 volts. Yep. What other voltage can we find? V4. Again, it's IT that's flowing through R4. So we focus on that one resistor. .5 times, what was R4? 15. 0.28 volts. Okay, keep the three significant figures. Okay. Right. Easy. Across that resistance, thinking one off. yeah, is effectively two go exactly that and take which is 30. I got right. Oh, yeah, sorry. I'm reading the wrong bit. So 12. Make 9, correct, Peter. Well, okay. Last three, so that's volts. I2 is equal to, yeah, V2 0.9 V2 over R3. Same voltage cost. Whatever. Oh, sorry, 50. .43 and then to more or less 6.5. Okay. In next page, you've got a question that takes a slightly different slant on it because it misses out. It gives you the current and 3 of the resistor values, not the 4th one. You're asked to find that. So, this find 1, I2, 3, and R3. Did I find 1? Volts. Yep. 3, 4. The 18s are 90, aren't they? Now what can we do? Voltage. Work out what? Five divided by. I'm actually now looking at that. Is there a way you can solve that problem? You do need it. It's a typo with me, that is. Do beg your pardon. Let me give you a voltage then. So if I give you... Why have I got to be careful here? That's got to be bigger than those two added together, otherwise we've got a problem, haven't we? Finish it off. Finish it off. How do we finish it off? V2 E minus
E1 minus
yeah 230 minus 25 minus 90 100 and what? 115 volts. Yeah, you can do. Well, you can work out. What you could do is you could work out now what the total of those two together is, and then rearrange the parallel formula to find R3. Or you can find I2 now take it away from the total to get I3, and then use I3 and the voltage to find the resistance. So there's two ways you could do it. So I2 is V2, it's 115, 2 is 15, can't be. Oh, you can't. Back. Boys. I fucked up again. Yeah, because you can't just do that because the circuit's got a total resistance that's causing that 5 amps to flow. My fault, I missed a piece of information off. I probably sat there last year and said, I need to add that on, and then gone back to the office and dragged something else ready for next year and forgot to do it. I do apologise, but you see where I'm coming from. It's about finding out from information you can just oops. And I do really recommend that you in the exam you're not going to get an all series question, you're not going to get an all parallel question, you're going to get a combination question. Yeah, so I would practice it, which are on the last 2 pages of this set of notes. I don't know off the top of my head, but I'm sure there are some out there. I know there's one, I think that's all about circuits, that I want to warn you to be careful of, because that uses actual current flow, electron flow, because the electrons actually go in the opposite direction to conventional current. So we just need to be careful of that, because that could cause confusion. I will always use conventional current flow. Alright?